All right. So, in our video lesson for today, what we are going to do is we're going to wrap up section 122, which was on multiplying polynomials. So we have a couple more practice problems and application problems with that. But before we get to that, I want to do a little bit more review with solving with rational exponents, just in seeing our work so far on those little half sheets. Enough errors where I feel like we need just a quick reteach on it. So we are going to be in our textbook. Okay, so open up to page 21 to start. This is where that section, let's see, that was section 112, where that was at, where we took our notes on that. I want you to copy down these two problems. Do it at the bottom of the page so you have some room to still complete that PBT, the problem-based math. Okay, just a quick review of these types of problems. So we did this about a week ago. We've seen it the past couple class periods, but I want to review it. So for solving with a rational exponent, like we have in this first problem, the biggest mistake I'm seeing is people are trying to distribute this -3 to both. You can't do that. Okay, there's a 3/2 power attached to this binomial here. Okay, but remember, our goal is to solve for x, is to get x by itself. Okay, so in order to get x by itself, we have to get rid of this -3. We have to get rid of this 3/2. And we have to do both of those first before we can even do anything with this 1. Okay, so the first thing we're going to always do is get rid of if there's any numbers in front. Reason we want to do that and not work with the exponent is if we start with the exponent, whatever we do to both sides, we're going to have to apply to the -3 also. Okay, so let's get rid of the -3 first. We divide both sides by -3. Okay, is cancel. Now we'd be left with 1 plus x to the 3/2 power equals -81 divided by -3. That'd be positive 27. Okay, so now the -3 is gone. Now we got to get rid of the 3/2. Okay, so this is where we'd raise both sides to that reciprocal exponent, 2/3 power. Okay, remember that that's going to cancel out, okay, these exponents. So we'd be left with just 1 plus x. Notice the parentheses are gone because there's nothing outside the parentheses anymore. Equals, when we put this in our calculator, we would put in 27 caret key parentheses 2 divided by 3. So we get 9. So 1 plus x equals 9. Now we solve. Subtract 1, subtract 1. X equals 8. Okay. Let's try another one. Okay, so 4x to the 2/3 power over 256. Okay, so again, first we have to get rid of the 4, not the 2/3. We just divide both sides by 4. Okay, so that would cancel out the 4s. Be left with x to the 2/3 power equals 256 divided by 4, 64. Okay, now I want to get rid of the 2/3 power. Raise both sides to the 3/2 power. X equals 64. 4 caret key. Oh, that didn't work either. 3/2. Get 512. Okay. Again, some of you guys are rock stars with this. Okay, and for those of you, be patient. You're doing great. But we had enough errors in those last couple of days of half sheets where I feel like we needed a reteach. I think everybody can use the practice with doing a word problem. Okay, so now let's take care of this PBT, problem-based task. Okay, so it says Yasmina is buying a new car. To estimate how her car will decrease in value or depreciate, she looks at the price of older versions of the same car. finds a similar car that's 2.5 years old. The original price of the car is $22,000. Current selling price $16,905. We have this function here that can be used to estimate the value of the car in any year T after being purchased for $22,000. The value D is used to calculate the new value of the car each year. Write an equation to help you estimate the value of the car C in any year T if the original purchase is $22,000. Let's just rewrite what we have here. C equals 22,000 times D to the T power. Okay, so our problem is saying write an equation, right? A function that we can use to find the value for any year T. Okay, so it's saying our variables should be C and T. What that's telling us is we need to find D. So in order to find D, we have to use the information they gave us. Okay, so C represents the current value. D represents what we're trying to find, the rate of depreciation, and T is the years that have passed. Okay, so 22,000, that represents the initial value. So first thing we have to do is put in the values they gave us. So C, that's the current value. Well, they said that was 16,905. Okay, so 16,905 is going to go in for C equals, so of 22,000 times D. Remember, D is what we're trying to find. And then we need to put in a value for T. Well, T is the time in years that have passed. So it said the car is 2.5 years old. Only thing that we should think about is if we're trying to solve, if we put in an exponent that's a decimal, we could do it. Okay, but we've been working with rational exponents, so let's change that to a fraction. That looks closer to what we've been doing. We can put in 2.5 into our calculator. You might know this one in your head, but this is the trick you can use, but it's a tough one. And hit math fraction, it's 5 over 2. Okay, that's the same thing as 5 over 2. Okay, the exponent, 5 over 2. Well, hopefully we're seeing now, this is just like the problems from the previous page. It's just a solving problem. Okay, so we're trying to get D by itself. So first we get rid of this 22,000. Okay, so we divide both sides by 22,000. So we do 16,905 divided by 22,000. We're going to round to a lot of places here intentionally because we don't want to round by a lot in the middle of the problem. Okay, so I'm going to round it to 4 places. 0.7684 equals, so the 22,000s are gone, D to the 5 over 2 power. Okay. Now we got to get rid of the 5 over 2 power. Okay, so this is where we raise it to that reciprocal exponent. Okay, so that's going to get us to our answer. We're going to be approximating here. We're not going to get an exact number. So we put in that decimal to the 2 over 5 power. You should get something like 0.899999 where it keeps going, really close to 0.8999. So we're going to say approximately 0.9. Just because we had 3 or 4 decimal places after the first one that were all 9. Okay, so then remember the question itself, it said write out a function where we have C and T as our variables that could find the value of the car after any number of years. Okay, so we're going to rewrite out our function. C equals 22,000 times no longer D. We just found that D is approximately 0.9 to the T power. That would be our answer. Okay, so the car is really worth 90% of its value each year. It's decreasing by 10% in value every year. Okay. All right. So again, if you were somebody where you're like, oh, I know all this stuff, like, then be patient. Okay. There's a lot of people, especially in this setting where this is a tough skill to learn remotely. So we're going to keep practicing it, but hopefully at the end of that, we're feeling a bit more confident with it. Okay. Let's wrap up what we started on Tuesday in class. So example 4. Okay, this is ramping things things up for us. So it says find the product, and then we have two trinomials on the inside. Okay, this is one where we're going to have to just stay really organized and take our time. I think it's on page 44. I don't have my page number on here. It got cut off at the bottom. Okay, so you guys are going to have to look and make sure that it's right around there, I know. All right, so remember, if it was double distributing, you'd multiply the first term to both, second term to both. Well, now it's a 3 by 3, a trinomial and a trinomial. It's the same process. Okay, so it's good review. It's just a little bit tougher because we have all these terms. Now we're going to start by multiplying the x to all three. So x times x squared, x to the third, x times 4y plus 4xy. One note, if you have two variables, try to stay consistent. It's going to look confusing if you do xy for one of your terms and then yx for the other one. So I'm just saying each of them I'm going to write x and then y. Then we have x times negative 5 minus 5x. Okay, now I'm going to multiply the y to all three terms. Okay, so y times x squared, and I'm going to stay consistent and put the x's first. So plus x squared y times 4y plus 4y squared, then y times negative 5 minus 5y. Lastly, the 1 to each of these. 1 times x squared plus x squared. 1 times 4y plus 4y. 1 times negative 5 minus 5. Now we got to really just look carefully and see if we have any like terms. Okay. You're probably thinking, how do I do standard form with multiple variables? We're just going to still put our highest power first, so we're going to keep this x to the third in front. Okay, but you are correct that from there really isn't a standard form since we have x's and y here. Okay, so we're just going to go term by term and see if we have any like terms. So 4xy, we need something that has an x and a y, no exponents. Not seeing any of that. We keep going. We have a minus 5x, nothing that just has an x. X squared y, nothing that has an x squared and a y. Y squared, nothing there. Minus 5y. We actually do have a plus 4y in here. So we do have some like terms in there. X squared, nothing that's just an x squared, and then a minus 5, that's the only one that's just a number. I'm going to write the plus x squared next. Oops, change this back to blue. Come on. Okay, so plus x squared. I'm just going to write everything with exponents of 2's next. It'll look a little bit cleaner, but there isn't a standard form here because we have multiple variables. We have a plus x squared y. We have a plus 4y squared. Okay, so I did all my ones with squareds. I'm going to put my 4xy next, plus 4xy. I'm going to put my minus 5x. Then I'm going to combine the y's, so negative 5y plus 4y, that's minus y. And then we still have the minus 5 at the end. Okay, that's a little tougher of an application problem. We're multiplying a trinomial by a trinomial. Okay. Last thing in this lesson, this is going to help us with an application problem that we're going to see on our homework. Okay, so on that same page where you have space, we're going to practice. I'm giving us a rectangle here. Okay, so we're going to assume that this is a rectangle. You can actually draw this out. And it says find the perimeter and the area of the rectangle. Okay, so remember perimeter is equal to adding all sides. You might be thinking, I only have 2 sides filled in. Well, here, if it's a rectangle, we could bring this 3x minus 4 over here. And we could bring this 2x plus 9 up here. Okay. So really, remember that if we're adding up all the sides, that's the same thing as 2 of our length plus 2 of our width. Okay, so our perimeter, we have 2 of those 2x plus 9s plus 2 of those 3x minus 4s. Now it's just a simplifying problem. Perimeter equals 2 times 2x, 4x, plus 2 times 9, 18, plus 2 times 3x, 6x, 2 times negative 4, minus 8. Combine our like terms, 4x and 6x, and 18 and negative 8. 4x and 6x, that makes 10x. 18 and negative 8. Did not give you units here, so maybe let's say we're measuring this in inches. Okay, so if we're talking about perimeter, we just say inches. Okay, that's a length. Okay, so that would be how you find the perimeter. Oh, come on. All right, now it says find the area. Okay, so next we got to find, oh, sorry about that. Next we got to find the area. I need some space to work, so I'm going to erase what we have here. One sec. Okay. All right. So now if we're going to find the area of this rectangle, area, remember that's just length times width. Okay, so in this problem, area would be these two sides multiplied together. We don't write it 4 times, right? Just these two sides. So 2x plus 9, parentheses around it, times 3x minus 4. We see how this application problem lends itself into our lesson, right? Because now this becomes a double distributing problem. So we'd multiply 2x to both. So we'd have 2x times 3x, that's 6x squared. 2x times negative 4 minus 8x. 9 goes to both. 9 times 3x plus 27x. 9 times negative 4 minus 36. Now we fully simplify. We have 6x squared. Combine the negative 8x and the 27x. So that'd be plus, in this case, 19x and a minus 36. Okay, now if we're talking area, then this would be in inches squared. Okay, so that's our lesson for today. You're going to notice that in our homework, it's application problems like this, and they will build in difficulty, where there's going to be some where we could have some trinomials in there. As our homework's going to be giving you a bunch of different rectangles. Even at the end, there's a challenge problem with a triangle, and it's going to say find the perimeter and area of your figures. Before you do that, there's a quick check that I want you guys to complete over what we had at the beginning. I just want to really get some feedback and see, okay, even if we use our notes, can we do these types of problems? Okay. So thanks. That's what we got for today.